Okay, so we're back and we're going to do some math. We've already determined that we had a 6.3 volt source. We have a forward voltage drop on the LED of 5 volts. And we want to try and keep that to 25 milliamps or less. So let's do the math. Let's figure out what we're doing here and how we're going to get around dropping that voltage down to something that is going to have a suitable 25 milliamp or less current flow. So, kind of got us a little drawing here. Get some light back on it a little bit better. This is a simplified version of our circuit. Here we have our two LEDs, right here and right there. This is the positive sides. We have this line here. Remember, that's the cathode side, so that's our negative side of our circuit. We're going to put our dropping resistors on the positive side, where we have 6.3 volts source. And this is the common ground for the whole radio. So we've got 6.3 volts for our supply. We want a 5 volt nominal forward voltage as stipulated by the LED, and we want to try to keep that to 25 milliamps or less. Now remember, when you're running a series circuit, everything that's in series drops all of the voltage. So we have 6.3 volts is going to have to be dropped between the positive and the negative sides of our circuit, between here and here. So this plus this has got to equal this. Well, we know those. And we're going to use our trusty old Ohm's law here to figure all this out. We got our 6.3 volts supply. We know our voltage, forward voltage on the LED is 5 volts. It's going to be dropping 5 volts. So the only thing we are really wondering is how many volts are going to be dropped by the resistor. Well, 6.3 minus 5 volts, 1.3 volts is dropped by the resistor. Now, just like we have to keep in mind in a series circuit that all the voltage will be dropped through the whole circuit, current in a series circuit stays the same through every component in that circuit. So we want to make sure that there's no more than 25 milliamps running through here, and therefore there's not going to be any more than 25 milliamps running through the dropping resistor. So we know that this dropping resistor is going to be dropping 1.3 volts. We want to limit the current through that resistor, and I just did this so it's easier to do the math, 0.025 amps. What kind of resistor do we need that's going to limit the current to this when it's dropping that? Well, let's just do the math. 1.3 volts divided by 0.025 amps gives us 52 ohms. At that point, you're looking through your junk box to find out what kind of resistors you got. Well, I didn't have a 52 ohm resistor. And believe it or not, they don't make a 52 ohm resistor. You can get a 51 ohm resistor, and that would probably still be okay. It would still be below the 30 milliamps that the maximum through the LED could handle. But we want to keep it to 25 milliamps or less. That way we have longer life, and we don't need the display being, eye-burning bright. So I went through the resistors I had, went through several packages, and I have lots of several thousand ohm resistors. The smallest one I could find was 120 ohm. Well, let's just give it a try. So I did the math on that, and I'll show you right here. We're still dropping the 1.3 volts. through our resistor, where we're going to use a 120 ohm resistor. Now remember, E equals IR, so I'm using the same equation. I came up with 0.0108 amps. I'm just going to round that to 0.011 amps, which gives us 11 milliamps. Now you're thinking, well, that's less than half of the current that you originally wanted to begin with. That's not a problem, but I still wanted to find out what it would look like. So I've set up a little temporary test circuit here, and I'll kind of go through this real quick, but I am going to show you one thing real fast. So here's our diode. This is just like the one that I'm going to put in the circuit. It's just like the one that we're testing right here. But I want you to notice something. On this diode, which is straight out of the package, see how those leads are not the same length? That's very, very important to pay attention to that. And you can actually see through this diode just a little bit. This makes it a little bit easier, especially if you have to cut the leads later. But that shorter lead is the cathode. That's the negative side. The long one's going to be going to positive. The shorter one's going to be going to negative. And remember, this is a diode. You put it in backwards, it don't work. No light come out. But you can also notice the shorter one, just in case you cut it later, you can't remember, oh my, which one was the shorter one. Typically, in a light emitting diode, I'm not sure if y'all can see that, but this lead inside there almost looks like it comes straight up, and the cathode comes up and almost has a little arrow that points at it. It's a big, wider area. So that's one way you can kind of keep track of which side's the anode, the positive side, or the cathode, the negative side. Now, I wanted to test this circuit, see what the illumination of the LED looks like, and find out, is it going to be bright enough to see? So I'm using my variable power supply here. You can't see the front of it, but I've turned it down to 6.3 volts. That's going to simulate the supply voltage in the radio. I have our LED. This alligator clip's just holding our dropping resistor to the longer leg of the diode, and then our positive hooked up to the other side of the dropping resistor, and our negative hooked up to the cathode side of the LED. I'll go ahead and reach over and turn this on. And apparently I unplugged the power supply, so give me just a second. It's always good to have this stuff plugged in before you make the video. I was about to turn on my soldering iron, and the cord was going to be a little too close, so I had unplugged it. Let's try this again. Oh, we got some light. And that's pretty bright. It's probably about half as bright as it would be, but that's going to be plenty bright to light up the meter and to light up the backlight for the LCD display. So you know what, we're just going to work with 120 ohm diodes. We're going to put 2 of them in the circuit, one for each of the pilot lamps that we already have. We'll replace those, and we'll have this thing shining pretty blue before you know it. And I'll go ahead and end this video now, and we'll come back at a later time, and I'll see if I can't have the resistors set up and ready to go into the radio, or possibly already in the radio. A little hard to hold the phone and solder at the same time, so I'll give you an update as soon as I can.